வாகை சூடவா.
Children, today we will see an important topic in our subject, the most basic concept of chemistry, percentage composition, empirical and molecular formula. I hope you are all thorough with the previous topic, which is mole concept, which is also very important for this topic. First, before we start with the topic, let me define what a chemical formula is. A chemical formula gives the representation of a molecule of a substance in terms of symbols of various elements present in it. That is, it gives you an idea of what are all the elements present in the formula. Once you know the elements present in the formula, you can find the mass percentage of each element present in it. That is, the relative amount of each element present in the compound. You are all familiar with simple examples of chemical formula. Say water, its formula is H2O, ozone. Its formula is O3. Now, if you see the formula, you get an idea of the elements present in it, and you can also get the mass percentage of the elements present in the compound. Now, let us go to the main topic of today's program, the empirical formula and molecular formula. Empirical formula of a compound is the simplest whole number ratio of the different types of atoms present in one molecule of the compound. Now, molecular formula, it is the actual number of different types of atoms present in one molecule of the compound. So, empirical formula is simple whole number ratio of the atoms. Molecular formula is the actual number of atoms present in the compound. Let me explain it to you clearly, taking an example. You all know the simplest aromatic hydrocarbon, benzene. Its molecular formula is C6H6. It has 6 carbon atoms and 6 hydrogen atoms. Now, the number 6 and 6, mathematically, when you reduce it to lowest terms, by dividing it by 6, you get C1H1, which is CH. Now, CH is the empirical formula of benzene. So, molecular formula of benzene is C6H6, empirical formula of benzene is CH. Now, how do you relate them? When you multiply empirical formula by a number, you get molecular formula. One more example I have given it to you, which is glucose. The formula for glucose, that is, the molecular formula for glucose is C6H12O6. Now, the numbers are 6, 12 and 6. When you reduce it to lowest terms, it becomes 1, 2 and 1. Now, the empirical formula for benzene becomes C1H2O1, which is CH2O. I think now the basic definition of empirical formula and molecular formula is clear to you. So, when you multiply empirical formula by a number, you get molecular formula. Clear, children? Next, let us find the relationship between empirical formula and molecular formula. As you all know, molecular formula for benzene is C6H6 and empirical formula is CH, and when you multiply empirical formula by a number which you represent it as N, you get molecular formula. That is the relationship between empirical formula and molecular formula of a compound. So, we can give a formula now. Molecular formula is equal to n into empirical formula, where n is a whole number and it is the number of times you multiply the empirical formula to get molecular formula. You can also bring about one more formula with respect to mass. If you know molecular formula, you can calculate molar mass. If you know empirical formula, you can calculate empirical mass. They will give you molar mass in the problem. Empirical mass, once you find out, you can calculate. So, when you divide molar mass by empirical mass, you can get n, and once you get n, if you multiply it by empirical formula, you will get the molecular formula for any organic compound or any compound. Now, as you all know, the empirical formula for benzene is CH and molecular formula is C6H6. So, by how many times you are multiplying the empirical formula? 6 times. So, when you multiply it by 6 times, you get the molecular formula. So, here n is 6. So, this is the relationship between empirical formula and molecular formula. Now, we will go to the main topic of the program, that is steps to find the empirical formula of a compound. The first step is you should know the percentage of the elements present in the compound, that is mass percentage of the elements present in the compound. Second, check if the percentage of oxygen is given in the compound if the organic compound contains oxygen. If not, leave the percentage of oxygen. Next, you should find the relative number of moles, that is the next step. Number of moles, it is nothing but given mass by molar mass if it is a compound or atomic mass if it is an element. Okay. So, relative number of moles you can calculate it. So, given mass is nothing but the mass percentage. So, mass percentage by atomic mass or molecular mass for an element or a compound. Once you find relative number of moles, next is simple mole ratio, that is the number of moles which you get, you have to find a simple ratio for it. So, divide it by the smallest number of moles value, that is see the values, check which one is the smallest value and divide all the relative number of moles by the smallest value. You get a simple mole ratio. Once the answers which you get are whole numbers, so straight away you can write it as whole number ratio. If not, you have to make it into whole number and then write it. Once you get whole numbers, the whole numbers are written as subscripts to the elements present in the compound to get empirical formula. After you find empirical formula, next you go to the molecular formula of the compound. There is no separate method to find the molecular formula of the compound. It is just continuation of the empirical formula of the compound. So, same steps have to be followed, which is finding the mass percentage, relative number of moles, simple ratio moles, whole number ratio. Till that it is the same. Once you get the empirical formula of a compound, the next thing is you have to find empirical formula mass. Empirical formula mass is found by just adding the atomic masses of the atoms of the elements present in the empirical formula. Okay. So, once you add the atomic mass, you get empirical formula mass of the compound. So, after you find that, you should know molecular mass. Molecular mass will be given in the problem, or if they give you vapor density, you can calculate molecular mass by just multiplying vapor density with 2. That is, molecular mass is equal to 2 into vapor density. So, once you know molecular mass and empirical formula mass, you can calculate n, and n is molecular mass by empirical mass. So, once you get n, multiply empirical formula with n and get the molecular formula. So, this is how you find the molecular formula of the compound. So, let me repeat it to you again. After you find empirical formula, find empirical formula mass. You will be given molecular mass. If not, if they give you vapor density, multiply it by 2 and get the molecular mass. Once you know molecular mass and empirical formula mass, you can find the value of N. Once you find the value of N, just multiply it by empirical formula, you will get the molecular formula of the compound. So, I think you are all clear with the steps to find the empirical formula and molecular formula of the compound. One more important point I would like to tell you is, check if the mass percentage of the elements are given in the problem. If it is not given, you have to calculate the mass percentage of the elements. So, to calculate the mass percentage of the elements, let me give you a formula for it. Mass percentage of the element is equal to N into N is the number of atoms present in the compound multiplied by atomic mass of that element into 100 by molar mass of the compound. N is the number of atoms. You all know the atomic masses of the elements present in the compound by into 100 because it is percentage by molar mass of the compound if you know the compound. So, if you do this, you can find the mass percentage of all the elements present in the compound. Let me make it clear to you by giving you an example. Let me tell you how to find or how to calculate the mass percentage of the elements present in a compound. Let us take a simple example, glucose. Glucose, its formula is C6H12O6, that is, it has the elements carbon, hydrogen and oxygen. How many atoms of carbon is there? 6. Hydrogen, it is 12. Oxygen, it is 6. You know the atomic masses of carbon, hydrogen and oxygen. It is 12, 1 and 16. First step is you have to find the molar mass of glucose or molecular mass of glucose. It is 6 into atomic mass of carbon plus 12 into atomic mass of hydrogen plus 6 into atomic mass of oxygen, which comes to 180. Now that you know molecular mass of glucose, now you can start calculating the percentage of the elements carbon, hydrogen and oxygen. So, how many carbon atoms are there? 6. Atomic mass of carbon is 12 into 100 by 180. So, you get 40%. Mass percentage of hydrogen. Number of hydrogen atoms, it is 12. Atomic mass of it is 1 into 100 by molar mass of glucose, which is 180. So, the percentage comes to 6.67. Mass percentage of oxygen. There are 6 oxygen atoms. Molar masses, atomic mass of oxygen is 16 into 100 by molar mass of glucose is 180. So, if you calculate, you get the percentage of oxygen to be 53.33%. There is one more way of easily calculating the percentage of oxygen, which is if you know the percentage of the other elements present in the compound, add the percentage of those elements and subtract it from 100. So, now you can check it here. Percentage of carbon is 40, percentage of hydrogen is 6.67, it comes to 46.67. So, when you subtract it from 100, you get the percentage of oxygen to be 53.33%. So, by this way also you can calculate the percentage of oxygen. I think now you are all familiar with how to calculate the mass percentage of the elements if you know the compound and its formula, if the mass percentage is not given in the problem. There is one more way to calculate the mass percentage, because sometimes in the problem weight of carbon dioxide and weight of water will be given. So, in that case you have to use the formula to calculate the percentage of carbon and percentage of hydrogen which is found by Liebig combustion method. So, if you know the masses of carbon dioxide and water, and if you know the mass of organic compound, you can find the percentage of carbon and percentage of hydrogen using this formula. That is, percentage of carbon is equal to 12 into mass of carbon dioxide, which is the data given, into 100 by 44 into mass of the organic compound, that is molar mass of the organic compound. You get the percentage of carbon. Same way you can calculate it for hydrogen. For hydrogen it is 2 into mass of water into 100 by 18 into mass of the organic compound. So using these two formulae you can calculate the percentage of carbon and hydrogen if mass of carbon dioxide and mass of water is given. Sometimes you won't know what the compound is. So in that case, first you will find the mass of carbon and hydrogen or oxygen, whatever is there. You will add all the three to get the mass of the organic compound. That is one more way to find the molar mass or the mass of the organic compound. Now we will go to example problems. The first problem is here. I will read it out for you. An organic compound present in vinegar. You all know what vinegar is. It is acetic acid. It has 40% carbon, 6.6% hydrogen and 53.4% oxygen. So here they have given you the mass percentage of the elements. So using the mass percentage of the elements, they are asking you to calculate the empirical formula of the compound. Now let us frame a table for it. So the columns are element, percentage, atomic mass, relative number of moles, simple ratio and simple whole number ratio. So the first column you write the elements which are given in the problem. What are the elements given here? Carbon, hydrogen and oxygen. Next column you write the percentage of those elements. Carbon percentage is 40, hydrogen percentage is 6.6, oxygen's percentage is 53.4. You know their atomic masses. Atomic mass of carbon is 12, atomic mass of hydrogen is 1, atomic mass of oxygen is 16. Now the next column is you have to find the relative number of moles. You all know the formula for calculating the number of moles. Mass percentage by atomic mass here because it is an element. So what is the mass percentage given here for carbon? 40. What is the atomic mass of carbon? 12. So you divide 40 by 12 and you get 3.3. The same way the mass percentage of hydrogen 6.6 is divided by 1 which is its atomic mass and you get 6.6. Mass percentage of oxygen is 53.4 and if you divide it by its atomic mass 16, you get the relative number of moles for oxygen which is 3.3. So the relative number of moles for carbon is 3.3, hydrogen it is 6.6 and oxygen it is 3.3. Now which is the smallest number here? 3.3. So the next column you have to find the simplest ratio. So divide all the relative number of moles by the simplest number or the smallest number. So the smallest number which is 3.3 is used to divide all these relative number of moles. So when you divide the relative number of moles carbon by 3.3 you get 1 because the relative number of moles of carbon is also 3.3. For hydrogen it is 6.6. If you divide it by 3.3 you get 2. For oxygen it is 3.3. So divided by the smallest number which is 3.3 you get 1. When you look at the simplest ratio they are all whole numbers. So you need not make it into whole numbers. Straight away you write it as 1, 2, 1 and this 1, 2, 1 is written as subscripts of the symbols of the elements present in the compound which is vinegar. So carbon subscript is 1, hydrogen it is 2 and oxygen it is 1. So the empirical formula for this compound is CH2O. Now we will move to example problem 2. Let me read the problem for you. A compound on analysis gave the following percentage composition. So what are the elements given here? Sodium, its percentage is 14.31. Sulfur 9.97, hydrogen 6.62 percentage and oxygen 69.5 percentage. So here they have given you the elements, they have given you their percentage composition. So you need not calculate mass percentage. They have given you oxygen also. So everything is given. Now we will move to the next part of the question. What are they asking you to calculate? Calculate the molecular formula of the compound. So you have to calculate empirical formula and you should proceed to calculate the molecular formula of the compound. Next, what is the data given? Assume that all the hydrogen in the composition is present in combination of oxygen as water. So after you find the molecular formula, you should write the molecular formula in such a way that all the hydrogen atoms which you get as simple whole numbers, they exist as water in combination with oxygen. They have also given you the molecular mass of the compound, which is 322. So mass percentage is given, elements are known, molar mass of the compound is known. So we can start with the problem. And one more thing what we will have to do, write the formula of the compound as a hydrated compound with water molecules. Clear all of you? Now let us frame the table again. First column element, next percentage, next atomic mass, relative number of moles, simple ratio moles, simplest whole number ratio. What are all the elements present? Sodium, sulfur, hydrogen and oxygen. Percentage for sodium is 14.31, sulfur 9.97, hydrogen 6.22 and oxygen it is 69.5. Atomic mass for sodium it is 23, sulfur it is 32, hydrogen it is 1 and oxygen it is 16. Sodium 23, sulfur 32, hydrogen you all know, oxygen also you know it is 16. Now divide the percentage, mass percentage of the elements by atomic mass. So what will you get? Number of moles. So 14.31 when you divide it by 23 you get 0.62. 9.97 when you divide it by 32 you get 0.31. 6.22 when you divide it by 1 you get 6.22 again. 69.5 when you divide it by the atomic mass of oxygen which is 16 you get 4.34. So now you have got the relative number of moles 0.62, 0.31, 6.22 and 4.34. Now which is the smallest number here? 0.31. So now divide all the relative number of moles by the smallest number which is 0.31. So when you divide relative number of moles of sodium which is 0.62 by 0.31 you get 2. For sulfur it is 0.31 by 0.31 which is 1. For hydrogen it is 6.22 by 0.31 which comes to 20. Oxygen 4.34 by 0.31 which is 14. So if you look at the simple ratio moles, all are whole numbers. For sodium it is 2, for sulfur it is 1, for hydrogen it is 20 and for oxygen it is 14. So straight away you can write it as whole numbers and you can write these numbers as subscripts to the symbols of the element present in the compound. So down sodium you write 2, sulfur you write 1, hydrogen you write 20, oxygen you write 14. So now the empirical formula of the compound is Na2SH20O14. Is that clear for all of you? Same method. You find the empirical formula of the compound. The question is you are asked to calculate molecular formula of the compound. You are asked to calculate the molecular formula of the compound. So you have to continue the problem by finding empirical formula mass. How will you find out empirical formula mass? So what is the formula, empirical formula? Na2SH20O14. 2 sodium atoms, 1 sulfur atom, 20 hydrogen atoms and 14 oxygen atoms. So multiply these atoms by their atomic mass. So atomic mass of sodium 23, so 2 into 23 plus 1 atom of sulfur, so 1 into 32 plus 20 atoms of hydrogen, atomic mass of hydrogen is 1 and 14 atoms of oxygen. So, 14 into 16 it is 322. So, it is similar to finding the molecular mass of a compound. So, now that you have found the empirical formula mass, it comes to 322. So, the given data, that is in the problem, if you see, molecular mass of the compound is given, which is also 322. So, can you see here, empirical formula mass is also 322, molecular mass is also 322. So, when both are the same, N will be equal to 1. So, what is N? Molar mass by empirical formula mass. So, some compounds, empirical formula and molecular formula will be the same because N is 1. So, because N is 1, you can straight away write the molecular formula of the compound because empirical formula and molecular formula are same, but just to show we will just multiply it by 1 and show. Molecular, now that you have calculated N, which is molar mass by empirical formula mass, which is 322 by 322, which is equal to 1. Now, the molecular formula of the compound is equal to 1 into empirical formula. So, which is 1 into Na2SH20O14. So, empirical and molecular formula are the same. So, now we have found the molecular formula of the compound, but they are asking you to find one more thing, to write the formula in such a way that all the hydrogens are present as water. How many hydrogen atoms are here? 20 hydrogen atoms. You all know the formula for water. It is H2O. Every 2 hydrogens need an oxygen atom. So, 20 hydrogen atoms are there. So, you need 10 oxygen atoms. But how many oxygen atoms are there? 14. So, it takes 10 from O14 and it comes out as 10 H2O as a hydrated salt. So, left out oxygen atoms is 4, 1 sulfur atom and 2 sodium atom. They combine to form sodium sulfate 10 H2O, which is hydrated sodium sulfate. Is that clear for all of you? So, sodium sulfate has water of crystallization. So, this problem is slightly different from the previous one. First problem we saw where you found only the empirical formula. The second problem, you found empirical formula, you also found molecular formula, and one more thing, what is extra here? You wrote all the hydrogen atoms present as water molecules and you have showed it as hydrated sodium sulfate. So, this is another problem which is slightly different. Now, we will move to the third problem. The third problem goes like this: a welding fuel, gas. So, it is a fuel, it is also a gas and it contains only carbon and hydrogen. So, they are very clear, it contains only carbon and hydrogen and there is no oxygen here. Okay? So, it should be a hydrocarbon. Burning a small sample of it in oxygen, so the fuel is burnt in oxygen and it gives 3.38 grams of carbon dioxide and 0.69 grams of water and no precipitate. So, here what do you understand? They have not given you the mass percentage of the elements. Instead, what have they given you? They have given you the mass of carbon dioxide and mass of water. So, you have to use the formula which I told you before to calculate the percentage of carbon and percentage of oxygen using Liebig combustion method. Okay? And one more thing, they have also given you a data, a volume of 10 liters of welding gas at STP is found to weigh 11.6 grams. So, here they have not given the molecular mass. Instead, they have given the volume of the gas at standard temperature and pressure. Okay? And also the mass at that volume, for that volume. So, everything is different here. They have not given mass percentage, they have not given molar mass, but they are asking you to calculate with the given data empirical mass, molar mass, molecular formula. Okay. So, let us go with the problem now. You all know the fuel gas contains only carbon and hydrogen and it is burnt in oxygen. Carbon, when it burns in oxygen, it gives carbon dioxide and hydrogen gives water. Okay. So, now they have given you the mass of carbon dioxide and mass of water. You all know in 1 mole of carbon dioxide, here you do not know what the fuel is. If you know the fuel, you can find the molar mass of the fuel straight, and you can use the formula which I told you. Mass percentage of the element A, any element A is equal to number of atoms into atomic mass of that element into 100 by molar mass of the compound. Here you do not know what the compound is. So, first you find the mass of carbon and the mass of hydrogen, then you add those two to get the molar mass of the fuel, then you find the percentage of carbon and percentage of hydrogen. This is the first step you will have to do. So, first to find the mass of carbon, you all know 44 grams of carbon dioxide contains 12 grams of carbon. Therefore, 3.38 grams contains how many grams of carbon? Find that. When you find it, you get the mass of carbon to be 0.922 grams. Same way in water, 1 mole of water contains 18 grams. 18 grams of water contains 2 grams of hydrogen. Therefore, what is the mass of water given here? 0.69 grams. So, for 0.69 grams, find the mass of water. It comes to 0.077 grams. Now, you know the mass of carbon, mass of hydrogen. If you add those two, you will get the molar mass of the fuel. So, the molar mass of the fuel is 0.999 grams. Now that you know this, you can calculate the percentage of carbon and percentage of hydrogen. Okay. So, what is the percentage of carbon? The mass of carbon divided by molar mass of the fuel into 100. What is the mass of carbon? 0.922. What is the molar mass of the fuel? 0.999 into 100. That comes to 92.3 percentage. Now, percentage of hydrogen 0.077 by molar mass of the fuel, which is 0.999 into 100, that comes to 7.7 percentage. So, first you have found the percentage composition of the elements. Is that clear for all of you? They have given you only the mass of carbon dioxide and mass of water, and they also clearly tell you there is no oxygen. So, it is a hydrocarbon. So, you find the mass of carbon and you find the mass of hydrogen, add those two to get the molar mass of the fuel. Once you know the molar mass of the fuel, you can find the percentage of carbon and hydrogen. So, now you have got the mass percentage of the elements present in the fuel gas, which is 92.3 percentage for carbon and 7.7 percentage for hydrogen. Now, we will go to the same table: element, percentage, atomic mass, relative number of moles, simple ratio, simple whole number ratio. What are all the elements? Carbon, hydrogen. What percentage have we found out? 92.2 and 7.77. You know the atomic mass, it is 12 and 1. Divide percentage by atomic mass, you get 7.7, 7.77. So, divide it by the smallest number, 7.70, you get 1 and 1. So, both are whole numbers. So, straight away you write it as subscripts. So, the empirical formula for the compound is CH. Now that you know the empirical formula, you can find the molecular formula, but you should note molecular mass. They have not given molecular mass, instead they have given a data to find the molecular mass. Let us go to that. Now, what is the data given? 10 liters of a gas, that is the welding gas which they have given you, at STP, standard temperature and pressure, it weighs 11.6 grams. So, it is at STP for 1 mole of any gas, what is the volume? 22.4 liters, which is the molar volume, which you all have studied before. So, according to the data, 10 liters of a gas weighs 11.6 grams. So, let us calculate for the volume, that is for standard volume, which is for 1 mole of a gas, which is 22.4 liters. So, when you calculate it for 22.4 liters, it comes to 26 grams per mole. What is that? It is molar volume. It is the volume occupied by 1 mole of any gas. So, straight away it is molecular mass of the welding gas, which is 26 grams. So, now we have got molar mass. You know the empirical formula. What is the empirical formula? CH. So what is the atomic mass of carbon? 12. Atomic mass of hydrogen is 1. When you add those two, you get the empirical formula mass for the welding gas, which is 13. Molecular mass is 26. What is the next step? You have to find out N. What is N? Molecular mass by empirical formula mass, which is 26 by 13, which is equal to 2. So now you have got N. So once you know N, you can calculate the molecular formula of the compound, which is molecular formula is equal to N into empirical formula, 2 into CH, which is C2H2. Can you guess the compound here? It is C2H2, which is used for welding purposes. It is acetylene. So is this clear for you? So same method, finding the empirical formula and molecular formula, but they have not given the mass percentage. So you have to find the mass percentage using Liebig combustion method formula to estimate carbon and hydrogen, and then they have not given molar mass. So using molar volume, you find the molar mass of the fuel, and using these two you find N. Once you find N, you find the molecular formula of the compound. Is that clear for you? Now we will go to the next problem, problem 4. It is slightly different. It was asked in NEET 2006 paper, 16 paper. Let me read the question for you. Suppose the elements X and Y, so the elements are X and Y, and they combine to form two compounds, which is XY2 and X3Y3. So X and Y, they combine, they form two compounds, XY2 and X3Y3. When 0.1 mole of XY2 weighs 10 grams, so the first compound, which is XY2, 0.1 moles of it weigh 10 grams. The second compound is X3Y3, 0.05 moles of it weigh 9 grams. They are asking you to calculate the atomic weight of X and Y. Atomic weight of X and Y. So you have to calculate the atomic mass of the elements. Slightly different. You have to go the other way around now. So the given data, what is the first compound? XY2. What is given? 0.1 mole of it weighs 10 grams. You always find molecular mass. So if you know for 1 mole of the compound, easily you can find the atomic mass of the elements present. So let us convert this to 1 mole. So if 0.1 mole of XY2 weighs 10 grams, what is it for 1 mole? So what is it for 1 mole? 0.1 is 10 means 1 mole will be 100. Same way for X3Y3, they have given the data as 0.05 moles weigh 9 grams. So what is it for 1 mole? So calculate it mathematically. For 1 mole, if you cross multiply and divide, you get 180 grams. So if 0.1 mole of XY2 weighs 10 grams, 1 mole of XY2 will weigh 100 grams. Same thing for X3Y3 you can calculate. So now you know 1 mole of XY2 weighs 100 grams and 1 mole of X3Y3 weighs 180 grams, or the mass of. So XY2, what are the elements present in XY2? How do you find? So 1 mole means its molecular mass. So molecular mass of XY2 is 100 grams. How do you find the molecular mass? You add the atomic masses of the elements present in the compound and you equate it to molecular mass. So now XY2, the elements are X and Y. You know 1 mole of X combines with 2 moles of Y to give the molecular mass of the compound. Same way in X3Y3, 3 moles of X combines with 3 moles of Y to give X3Y3, and it is equal to 180 grams. So now let us change it into a linear equation mathematically. So for the first compound XY2, let us write it as X. So 1X plus 2Y is equal to 100. And the second compound 3X plus 3Y is equal to 180. So which is clear, 1 mole of X combines with 2 moles of Y and the molecular mass of the compound is 100. For the second compound, 3 moles of X combines with 3 moles of Y and the molecular mass of the compound is 180. Now let us solve these linear equations. When you solve it, you get X to be 40 and Y to be 30. What is this X and Y? It is nothing but the atomic mass of the elements capital X and capital Y. Is that clear for you? They have given two elements and they form two compounds XY2 and XY3. The data is 0.1 mole of the first compound, its weight is 10 grams. 0.05 moles of the second compound, it weighs 9 grams. Okay. So, find out for 1 mole. 1 mole is nothing but its molecular mass. So, how will you find the molecular mass? Add the atomic masses of the elements present in the compound. For XY2, atomic mass of X into 1 plus atomic mass of Y into 2 is equal to 100. Let us write that atomic mass of X as small x and atomic mass of Y as small y and equate it and make it into two linear equations and solve it to get X and Y, which is the atomic mass of the elements X and Y in the compounds XY2 and X3Y3. Is that clear for all of you? Now, we will move to the next problem. Example problem 5, which was asked in one competitive exam in 2015. 20 grams of magnesium carbonate sample. It decomposes on heating to give carbon dioxide and it gives 8 grams of magnesium oxide. So, magnesium carbonate, it decomposes to give magnesium oxide and carbon dioxide. The sample which you have taken is 20 grams. It gives 8 grams of magnesium oxide. So, if you take 20 grams of magnesium carbonate, it is giving 8 grams of magnesium oxide. They are asking you to find the percentage purity of the sample which is given. So, let us write the equation first. Magnesium carbonate decomposing to give carbon dioxide and magnesium oxide. So, MgCO3 decomposes, you should write heating symbol there, MgO plus CO2. So, 1 mole of magnesium carbonate, when it decomposes, it gives 1 mole of magnesium oxide and 1 mole of carbon dioxide. What is 1 mole? Well, it is nothing but molar mass. So, when you calculate the molar mass of magnesium carbonate, it is 84 grams. 84 grams of magnesium carbonate gives 40 grams of magnesium oxide. 84 grams of magnesium carbonate will always give 40 grams of magnesium oxide if it is 100% pure. Now, the given data is you have got 18 grams of magnesium oxide from 20 grams of magnesium carbonate. So, for 8 grams of magnesium oxide, how much amount of magnesium carbonate you should take? So, when you solve it, the magnesium carbonate which has decomposed to give 8 grams of magnesium oxide is only 16.8 grams. It is only 16.8 grams. Actually, the given sample is 20 grams. So, the rest are impurities. Now, you have to find the percentage purity. How will you find out? The amount of magnesium carbonate divided by the total sample amount of the sample which you have taken into 100. So, what is the amount of magnesium carbonate which has given you 8 grams of magnesium oxide? It is only 16.8 divided by what is the sample amount which you have given 20 grams into 100. So, the answer comes to 84%. So, the percentage purity of magnesium carbonate in the sample is only 84%. Is that clear for all of you? Now, so I have given you 5 different problems. The first one which helps you to find out only empirical formula. The second one, you were able to find out molecular formula, and one more important thing, you wrote the water molecule as a hydrated compound. The third one, they didn't give you, in the data, percentage of the elements were not given. So, you found the mass percentage of the elements and you also found the molar mass of the compound because molar mass was not given in the third problem, and you found it using standard volume. Fourth problem, you found the atomic mass of the elements. They gave you what? They gave you the number of moles and you found for one mole of the compound and you found the atomic mass of the elements. That was a NEET problem. And example 5, you found the percentage purity of the sample. So, all 5 problems are different. Now, let me give you a few questions which you can practice at home. let me give you hints for the questions also to solve it easily. See the first question, what is the percentage of carbon in carbon dioxide? Carbon dioxide, percentage of carbon. So what should you do here? Mass percentage. So first what should you calculate? Molar mass. Then you all know the formula. What is mass percentage of an element A? Number of atoms of that element into atomic mass of the element by molar mass of the compound into 100. How many atoms are here? 1. What is the atomic mass of carbon? 12. By what is molar mass of carbon dioxide? 44 into 100. If you work out this, you will get the percentage of carbon in carbon dioxide. Now we will move to the second problem. The empirical formula of an organic compound is CH2O. They have given the empirical formula of the compound. Next, its vapor density is 45. What is the molecular formula of the compound? So, empirical formula is given. They are asking you to calculate molecular formula. Its vapor density is given. So, to calculate molecular formula, you should know N. How will you calculate N? It is molar mass by empirical formula mass. So, because you have empirical formula, you can calculate empirical formula mass. To calculate molar mass, they had given you vapor density, because they have not given the molar mass straight. They have given you vapor density. So, you have to calculate molar mass by multiplying by 2 to get molar mass. Multiplying what by 2? Vapor density by 2 to get molar mass. So, now you have molar mass 45 into 2, which is 90. Find the empirical formula mass, divide molar mass by empirical mass, you will get N. Once you know N, you can find the molecular formula of the compound by multiplying the empirical formula CH2O by N. Is it clear for you? Now we will move to the next question. In a compound C9H9N, what are the atoms here? Carbon, hydrogen, nitrogen. You know the atomic masses. What are the atomic masses? Atomic mass of carbon is 12, hydrogen it is 1, and nitrogen it is 14. It is present in the ratio 9 is to 1 is to 3.5. 9 is to 1 is to 3.5 by weight. Molecular mass is given. They are asking you to calculate the molecular formula of the compound. So, first what you should do here is, they have given the atoms carbon, hydrogen, nitrogen ratio they have given. Divided by their atomic mass, you will get relative number of atoms, relative moles of atoms, then simple ratio, then simple whole number ratio. Same method. Instead of mass percentage, they have given the ratio. So, straight away you take this 9, 1 and 3.5 as mass percentage and divide it by the atomic mass to get the relative number of moles. Then the rest is the same. So, once you find empirical formula, you can calculate empirical formula mass. Molecular mass is given. So, easily you can find the molecular formula of the compound by dividing molecular mass by empirical formula mass, where you get N, and once you know N, multiply it by empirical formula to get molecular formula. And the fourth question is almost the same, but they have stopped with the empirical formula. So, here what are the elements? Calcium, carbon and nitrogen, 3 elements. So, 20, 6 and 14, this is the ratio. So, divided by their atomic mass. So, atomic mass for calcium, what is the atomic mass for calcium? 40. For carbon it is 12. For nitrogen it is 14. So, divide, find the relative moles, simple ratio moles, whole number ratio and write the whole numbers as subscripts. You get the empirical formula of the compound. Now, the last problem is, the atomic mass of a metal is 56. What is the empirical formula of its oxide containing 70% of its metal? So, the compound here is metallic oxide, a metal and oxygen. They have given atomic mass of the metal. You know the atomic mass of oxygen, which is 16. They have given the percentage composition of the metal, which is 70%. So, what can you find out? You can find the percentage of oxygen, which is what? 100 minus 70, which is 30. So, now you know percentage composition of metal and oxygen. You know atomic mass of the metal and atomic oxygen. The rest is the same. Find relative number of moles, simple ratio moles and simple whole number ratio to get the empirical formula of this metallic oxide. Thank you. Okay, I think you are all familiar with what we have learned today. Let us have a recap. So first we saw what a chemical formula is, to know the basics. Next, I gave you the definition for empirical formula and molecular formula, and I also told you how they are related. That is, molecular formula is equal to n into empirical formula, where n is the number of times you multiply the empirical formula to give molecular formula. Next, I told you the steps to find the empirical formula. You should know the percentage composition, you find relative number of moles, you find simple ratio moles, and you find the whole number which is written as subscripts to find the empirical formula. Then continuation of empirical formula is finding the molecular formula of a compound. So I hope you remember this. So once you find empirical formula, next you find empirical formula mass, then you should know molecular mass, otherwise you find molecular mass, then find the value of n by dividing molecular mass by empirical mass, and once you get n, multiply it by empirical formula to give molecular formula. So these are the steps to find the empirical and molecular formula of a compound. If they give you mass percentage, it is easy to find the empirical formula and molecular formula. If not, use the formula which I told you to do it. Either they will give you the percentage, that is, either they will give you the mass of carbon dioxide and water, or you will know the compound, from that you can find the mass percentage of the elements present in the compound. Next, I also gave you problems, which the first problem helped you to find only the empirical formula. Second problem, you found empirical formula, molecular formula, and you also wrote the water molecules as water of hydration. Next, third problem, you didn't know what the compound is, so you found the percentage of the elements present in the fuel, then you found molecular mass, then you solved the problem to calculate empirical formula and then molecular formula. And example 4 was different, which is they have given you the compounds and they have given you the moles, from that you found the atomic masses of the elements X and Y. And fifth problem, they gave you the sample and they asked you to find the percentage purity, which was very easy for you. So I think you are familiar with all the problems related to this topic, empirical formula, molecular formula and percentage composition. Hope you enjoyed, and let us meet you in the next session. Hope you understood everything clearly. Work out the practice problems and let's meet in the next session. Thank you.
இந்நிகழ்ச்சியை பற்றிய தங்களின் மேலான கருத்துக்களை கீழ்க்கண்ட முகவரிக்கு கடிதம் மூலமாகவோ, மின்னஞ்சல் மூலமாகவோ, குறுஞ்செய்தி மூலமாகவோ தெரியப்படுத்தலாம். அனுப்ப வேண்டிய முகவரி: சிறப்பு அலுவலர், கல்வி தொலைக்காட்சி, 8ஆம் தளம், அண்ணா நூற்றாண்டு நூலகம், காந்தி மண்டப சாலை, கோட்டூர்புரம், சென்னை 6,85,000. தொலைபேசி எண் 7824015000.